3, 2, 1. Booster ignition. And liftoff.
Take a look. This is the moon, familiar to all of us, the most studied world beyond Earth. Its surface was mapped in the 17th century. Humans have landed on it 6 times, measured its mass and dimensions, analyzed its soil. And now, look at this gray, unfamiliar world. But it's the same moon, the side we never see from Earth. This is the great paradox of the moon. We've sent dozens of probes to it, studied its surface thoroughly, brought 382 kilograms of lunar rocks back to Earth. Yet we still can't answer one question. Why does the moon look like it was assembled from 2 completely different halves? And now, half a century after Apollo, the latest Artemis II footage gives us a new look to the moon and its hidden side. Using the latest scientific data and imagery, the animation studio ReYOUniverse shows you the moon like you've never seen it before. The complete geography of the moon. What is hidden on the far side? 4.5 billion years ago, the young Earth collided with a large protoplanetary body, Theia. After the impact, part of the material was thrown into orbit and eventually formed the moon. For a rocky planet like Earth, it is an unusually large satellite, 3,474 kilometers in diameter, nearly 1/3 the size of Earth itself. Only 4 moons in the solar system are larger, and all of them orbit gas giants. Yet, despite its proximity to us, it's an entirely different world. Gravity on the moon is 6 times weaker than on Earth. As a result, a person weighs 6 times less there and can move in long sprint-like jumps. At first sight, this may seem like an advantage, but behind it lies a hostile environment. The moon has neither an atmosphere nor a magnetic field. On Earth, these act as a shield. The magnetic field deflects the solar wind, a stream of charged particles that the sun continuously releases into space. The moon has no such protection. Radiation reaches the surface directly. Also, light does not scatter there. The sky is always black. Temperatures swing from 121 degrees Celsius during the day to minus 171 degrees Celsius at night. Inside, the moon is structured like a layered cake, a crust, a mantle, and a partially molten iron core. It was this hot interior that once made the moon geologically active. After the impact, its interior remained red hot for a long time. Molten rock churned beneath the surface, while volcanoes raged above. On the near side of the moon, where the crust is thinner, lava flooded vast plains. These are the same dark patches visible to the naked eye from Earth. Known as mare, Latin for sea, they were once mistaken for actual bodies of water by early astronomers, and the name stuck. However, the crust on the far side is thicker, so lava barely escaped. As a result, its surface is brighter, marked almost exclusively by impact craters. 2 completely different worlds on a single moon. And if we had lived 4.5 billion years ago, we might have seen both sides of the moon. But Earth's gravity intervened. It pulled slightly harder on the near side of the moon than on the far side. This created stress and friction within the moon, causing it to lose rotational energy. Gradually, it slowed down and settled into a stable position, always facing Earth with the same side. That is how we came to know one side of the moon and remain strangers to the other. The first images of the far side were transmitted only in 1959 by the Luna 3 spacecraft, and the photographs from Artemis II have only emphasized the contrast between the two faces of our natural satellite. Let's begin our journey on the far side of the moon, the side forever hidden from us. We'll illuminate it thoroughly, and you'll see what has remained invisible for centuries. Imagine an impact so powerful that it gouged out a hole half the size of the United States. That is exactly what happened on the far side 4.2 billion years ago. This is the South Pole, Aitken Basin, the largest impact crater on the moon, and one of the largest in the entire solar system. It stretches more than 2,500 kilometers across and reaches depths of up to 8 kilometers. This scar covers almost the entire southern region of the moon's far side. Part of this basin can be seen in the Artemis II images, but the way it originally looked has been obscured by younger craters. In the northwestern outer part of the basin, among ancient craters, the dark Mare Ingenii suddenly emerges. Its very existence here is already a mystery, since the far side contains almost no lava plains. But upon closer inspection, you can see even stranger objects. Pale, swirling patterns, as though someone ran a finger across the surface, and the mark remained for billions of years. These are lunar swirls. Beneath these areas, there likely lies rock that creates a weak magnetic field. It partially deflects the solar wind, preventing the surface here from darkening as much as in other areas. To the northeast, a mysterious structure with nearly perfect circular edges emerges on the surface. Tsiolkovskiy Crater is one of the most prominent craters on the far side, about 185 kilometers in diameter. The impact that created it was so immense that it first crushed the surface inward. Then the rock bounced back and surged upward. At its center rises a peak, a frozen moment of that explosion. Further north, the surface is mostly bright, but one large darkened region stands out here. It looks alien in this landscape, like a fragment of a different moon. This is Mare Moscoviense, 280 kilometers in diameter. Apparently, the impact that formed this basin weakened the crust in this region. As a result, molten rock was able to break through to the surface and flood the area with lava. And yet, this is an exceptional case for the far side. Here, hot molten material was usually unable to break through. So the landscape was shaped primarily by cosmic impacts. Hertzsprung in the southeast is exactly such a place where lava never reached the surface. It's an impact basin 570 kilometers wide that formed 4 billion years ago. At that same time on Earth, the primordial soup was bubbling, a mixture of chemical compounds from which life would eventually emerge. More than 2 billion years later, another crater formed near the edges of Hertzsprung, Vavilov, about 98 kilometers in diameter. By that time on Earth, multicellular organisms had already appeared. In the Artemis II images, one can immediately see that it's younger. Neighboring craters have long since been worn down by impacts, while Vavilov's shape remains almost untouched, with high, sharply defined rims. Moving eastward, we arrive at Mare Orientale, the boundary between the two halves of the moon. This is the youngest of the moon's large impact basins, and the best preserved. Lava barely flooded its interior, so the impact structure remains intact. 3 concentric rings, like a giant target. From Earth, we can only see its edge. Artemis II became the first mission whose crew saw this sea in its entirety. To the northeast of the Mare Orientale, another dark spot stands out in the images: Grimaldi Crater. Here, dense rock layers were brought closer to the surface after the collision. Together with solidified lava, they made this region heavier than the neighboring areas, meaning gravity is slightly stronger here. Such areas of increased gravity exist in many of the Moon's impact basins and are known as Mascons. You cannot see these regions in photographs of the Moon. To the naked eye, they appear to be just another dark sea, but for any spacecraft in orbit, they can pose a hidden danger. Flying over them, the first satellites seemed to fall into an invisible pit. Gravity here becomes stronger, and their trajectories could be thrown off course. And that's the essence of the Moon's far side. It appears completely dead, yet beneath its landscape lie invisible gravitational anomalies, areas of weak magnetic fields, and traces of the most ancient impacts that forever changed our Moon. Now, we're moving to the near side, the one we observe every clear night. Let's examine every detail up close. One of the largest traces of a recent impact lies in the southern part of the Moon's near side. This is Tycho Crater. Its diameter is about 85 kilometers, and it's quite young by lunar standards. Approximately 110 million years old. You have definitely seen it during a full moon, even with the naked eye. It's the most noticeable bright spot on the Moon. After the impact, bright streaks of ejected rock radiated outward in all directions, stretching for thousands of kilometers and standing out sharply against the Moon's surface. But not all lunar features are so easy to spot. Some are visible only through a telescope when the sun is low, and shadows make the terrain more visible. For example, there is a strange straight line crossing the surface closer to the central regions of the near side. It appears perfectly straight, almost artificial. It's no surprise that it was named Rupes Recta, the straight wall. In reality, it is a slope about 300 meters high and 110 kilometers long, but this is only the surface trace. The fault that created it extends 42 kilometers deep. This formation emerged as the Moon gradually cooled and contracted. The surface could no longer withstand the stress, and fractures formed. Along one of these cracks, an enormous slab of rock simply slid downward under its own weight. To the west of the central regions lies one of the most colossal megastructures on the Moon. It can be seen without a telescope, simply by looking up on a clear night. This is Oceanus Procellarum, the Moon's largest dark plane, covering 4 million square kilometers. Roughly half the size of Australia, larger than all of Western Europe. Volcanic eruptions stretching across billions of years flooded this region of the Moon forever. And in the northern part of this lava plain, one bright spot stands out in particular. This is Aristarchus Crater. With a 40-kilometer diameter, it's one of the brightest objects on the Moon, and one of the most restless. Here, observers have witnessed things that should not exist on a dead world. Flashes of light, a ghostly haze, surfaces that suddenly change brightness without explanation. What exactly causes these phenomena remains unclear. Perhaps gases occasionally seep out from the Moon's interior. Or perhaps the cause lies in lunar dust and unusual light scattering above the surface. Near the crater, a gigantic winding line stretches across the surface, resembling a dried-up riverbed. It snakes across the plain for hundreds of kilometers, as though water once flowed there. even though no water ever existed here. This is Vallis Schröteri, the Moon's largest lava channel, left behind by streams of molten lava billions of years ago. Southwest of Aristarchus lies another striking sign of volcanism, the Marius Hills. This is a vast field of rounded elevations known as lunar domes. They usually occur in groups and resemble ordinary hills, but these are neither impact marks nor folds in the crust. They are solidified deposits of viscous lava. Instead of flowing freely, the lava slowly oozed upward from the interior and solidified in place. Near these domes lies something far stranger, the Marius Hills Pit. In photographs, it appears as a perfectly black hole in the surface, as if the moon had simply collapsed in on itself. It's neither a crater nor a shadow. Billions of years ago, lava flowed here across the surface like a river. The top layer cooled and hardened, forming a crust. But lava continued to flow under it, like water beneath ice. When the flow dried up, a cavity remained beneath the crust. The solidified upper layer couldn't support its own weight and collapsed, opening this dark pit on the surface. Another such depression can be seen in the eastern part of the near side, in Mare Tranquillitatis. Possibly a network of underground caves stretches beneath it. These pits are almost like caves on Earth, and they may be the safest places on the moon. After all, the lunar surface has no atmosphere. Temperatures fluctuate violently. Radiation is intense. Meteorites constantly strike the ground, and even the soil itself is hostile. Scientists once feared that the moon's surface was covered in such a thick layer of dust that it would drown a spacecraft upon landing. That fear proved wrong, but it didn't make lunar dust any less dangerous. It is fine, sharp, and highly abrasive. On Earth, grains of sand are worn smooth by water and wind. On the moon, that never happens. Every day, millions of micrometeorites strike the lunar surface, melting the soil and creating microscopic shards of glass. That is why lunar dust is like powdered glass. During the Apollo missions, it damaged spacesuits. But it wasn't just its destructiveness that was striking, it was also the smell. When astronauts brought dust into the module and removed their helmets, they smelled a pungent odor of burnt gunpowder. By the end of the expeditions, the astronauts' gloves had worn down so badly that the skin on their hands was damaged and blood seeped from beneath their fingernails. However, conditions are milder inside these underground cavities. The thick layer of rock overhead provides partial protection from radiation and micrometeorites. Most likely, even lunar dust doesn't rise and spread so easily here. And most importantly, NASA calculations suggest that the temperature inside some lunar pits stays around 17 degrees Celsius, constantly. The rock overhead acts like a thermos, and inside these lunar caves, the temperature is like a cool room. Outside, minus 171 degrees. Inside, plus 17, a difference of 150 degrees just by going below the surface. But for now, these pits remain targets for future exploration. And as we continue toward the northwestern regions of the moon's near side, we arrive at places directly tied to the history of lunar exploration itself. This is Mare Imbrium, a massive impact basin about 1,160 kilometers in diameter. And it is the most treacherous region for orbiting spacecraft. Hidden here are the moon's largest Mascons. Those same regions of increased gravity. Because of them, early spacecraft experienced slight deviations in their orbits. The first successful planetary rover, the Soviet Lunokhod 1, operated on the western plain of Mare Imbrium. It traveled more than 10 kilometers, transmitting panoramic images of the surface and studying the lunar soil. It also carried a laser reflector. Scientists on Earth still bounce laser pulses off such reflectors today to measure the distance to the moon with extraordinary precision. These measurements confirmed something unexpected. Our satellite is slowly drifting away from us by about 3.8 centimeters per year. Imperceptible to us, yet irreversible. A little farther north, the impact that formed Mare Imbrium created another landscape feature, the Lunar Alps. Among them rises the lunar Mont Blanc, reaching a height of about 3,600 meters. By Earth standards, that is comparable to major alpine mountains, except here there is no snow, no atmosphere, and no life. And farther northwest, along the edge of the basin, the terrain curves into a broad arc. This is Sinus Iridum. Long ago, this was a crater, but lava partially flooded it, leaving behind only an elegant semicircular rim framed by the Jura Mountains. From orbit, it resembles an amphitheater, as though someone deliberately designed this formation. To the southeast of this basin stretches another great mountain range, the Lunar Apennines. They extend for approximately 600 kilometers. Some peaks here rise 5 kilometers above the basalt plain, almost as high as Denali, the tallest mountain in North America. It was here, at the foot of the Apennines, that Apollo 15 landed. Its primary destination was Hadley Rill, a winding channel about 80 kilometers long. From orbit, it resembles a riverbed, but no water has ever flowed here, only lava. This was the first mission equipped with its own lunar rover. For the first time, the astronauts could drive away from the landing site and truly explore the surrounding terrain. They brought back basalt and rocks 3 billion years old, direct witnesses to the time when lava once churned here. But they did leave something behind. At the foot of Hadley Rill, a small aluminum sculpture called Fallen Astronaut stands beside a plaque bearing the names of 14 fallen space explorers, both Soviet and American. This is the first and only memorial in another world. Apollo 15 also left seismographs on the surface, and they recorded something unexpected: moonquakes. Earth pulls on the moon with its gravity. Meteorites strike the surface. Residual heat hasn't yet completely dissipated, so from time to time, the moon is shaking. Some quakes reach magnitudes of 5.5 and last for more than 10 minutes. Farther east, in the Taurus Littrow Valley near Mare Serenitatis, we can still find bright remnants of explosive volcanic eruptions. The astronauts of Apollo 17 discovered orange soil in this region.
Wait a minute. What? Weather reflections. I've been fooled once. There is orange soil. Well, don't move it till I see it. It's all over. Orange. Don't move it till I see it.
A scattering of tiny beads of volcanic glass. Gases blasted molten rock upward, spraying it into fine droplets. The droplets cooled rapidly in flight, and the molten material solidified not into stone, but into glass. On the surrounding slopes, astronauts also noticed tracks left by enormous moving boulders. Dislodged by moonquakes, the rocks rolled downhill, leaving traces that will last for millions of years. The Apollo 17 rover still stands here today. It was deliberately parked so its camera could film the module's liftoff. Nearby are the descent stage of the Challenger module, scientific instruments, and the flag. Equipment was left behind not only here, but at landing sites all across the moon, visited by different missions. These sites are so numerous that there are entire maps marking the locations of abandoned equipment. Most of these machines are not functioning, but they all remain on the moon as monuments to humanity's presence in another world. Today, however, scientists' attention is shifting toward the lunar poles. After all, they may hide resources for future expeditions. At the northern edge of the moon, the sun merely skims along the horizon, barely illuminating deep craters. At the South Pole, this effect is even more extreme. There are regions here where sunlight has not reached the surface for billions of years. One such place in the south is Shackleton Crater. It's hard to imagine a more lifeless landscape, eternal darkness and extreme cold, reaching minus 230 degrees Celsius. Yet, it could harbor something that seems almost impossible for the moon: water ice. Scientists estimate that the shadowed craters at both poles of the moon could contain hundreds of millions to several billion tons of ice. That would be enough to supply entire cities with water for years. It is believed that comets and micrometeorites delivered this water to the moon. And in these polar traps, where sunlight's heat doesn't reach, it remained preserved in frozen form. And this is no longer just a hypothesis. At first, orbiting spacecraft detected signs of ice based on surface reflections and infrared data. Then in 2009, the L-Cross mission deliberately crashed a rocket stage into Cabeus Crater, southeast of Shackleton. The impact blasted a cloud of material into space, and instruments detected water within it. According to modern estimates, the upper meter of soil in the permanently shadowed regions of the South Pole may contain around 5 liters of ice per square meter. And if there is water on the moon, one of the key conditions for life, then another question arises. Could life ever have originated here? Most likely not. The moon is far too hostile, with no atmosphere and intense radiation. But lunar ice theoretically makes it possible to sustain life from Earth. After all, humans have already visited the moon, but they did so in sealed spacesuits, protected by technology. A few seconds without this would kill us. But are all terrestrial creatures as fragile as we are? It turned out that microscopic life forms may be far more resilient. After the Apollo 12 mission, parts of the Surveyor 3 spacecraft, which had spent 2.5 years on the moon, were brought back to Earth. They were found to contain terrestrial bacteria, which may have survived the radiation, temperature fluctuations, and lack of an atmosphere. Later, however, it turned out that the bacteria were most likely introduced by the scientists themselves when opening the containers on Earth. An accidental contamination, nothing out of the ordinary. But we can't be 100% sure, and if bacteria really survived on the moon, it means life is more resilient than we think, and one day, our moon could offer it another chance. Especially since humanity is already moving in that direction. And while Artemis 2 only explored the moon from afar, future missions may eventually establish a base here and extract water, oxygen, and fuel from lunar ice for expeditions. With the exploration of the moon, humanity will be able to move on to other bodies in the solar system, and perhaps even beyond it. After all, launching ships from here will be much easier. Gravity is weaker, and there is no dense atmosphere. And perhaps one day, looking at Earth from the moon will feel as natural to us as looking at the moon from Earth does today. What was once only done by astronauts can become part of everyday human life. And with every step humanity is already taking toward the moon, that future feels less and less impossible.